do we describe matter? What type of properties can we use? So properties, we have three words here that are in bold. These are words that should be committed to memory. Uh, Properties are the characteristics that each substance gives, or that each substance has, that gives it a unique identity. Okay, so that's fine, but that's too obscure. We want to nail it down a little bit more than that. So chemists split the world into two different categories: physical properties and chemical properties. And each one we have different properties that we can identify. So let's first talk about physical properties. Well, physical properties are the properties that a substance shows by itself without interacting with anything else. It's just whatever property it has by itself. And we can use our three out of our five senses to identify these physical properties. We can use sight. If you look at something, you can describe it to me. We can use sound. Some things sound different than other things. And touch. We can touch something and we can figure out if it's smooth, if it's rough, if it's cold, if it's hot. We can figure out those types of physical properties. Now, the other two senses that we have, smell and taste, those actually deal with the chemistry. So those would be dealing with the chemical properties, not the physical. So these three are the physical properties. And if I give you an example, here we have solid ice and we have liquid water. Both of these are composed of water molecules. You can see here, if we zoom in, the solid ice has water molecules that are arranged in a nice structured manner, and while the liquid water has water molecules that are kind of flowing around each other. But they're both made up of water molecules. So the chemistry behind both of them is the same. However, the appearance of them is very, very different. The solid water, ice, you can tell me if you're looking at ice or liquid water. Very easy to distinguish. So we can use our those three senses to identify physical properties. We have some measurable properties that we can, some measurable physical properties. So here we know that if I gave you a piece of ice, you could go to a scale and weigh it, and you could figure out what its mass was. So mass is a physical property of ice, a physical property. Volume, I could give you a tape measure, you could measure out the dimensions of this ice cube, and you could tell me what the volume is of that ice. So volume is a physical property. And density we haven't talked about yet. We will talk about it on the next video. Density is a nice relationship between mass and volume, and that, since mass and volume are both physical properties, density has to be a physical property. We're going to be dealing with density a lot in this course, so for right now, just know that it is a physical property. So the properties themselves are all fine and good. You can already identify a lot of the physical properties just by sight alone. Now, the changes that physical properties can undergo, physical changes, are, in my opinion, much more interesting. So let's see what a physical change is. Physical change is where we've altered the form of the material, of the matter, without altering any of its chemical properties. So here, if we have ice and we heat it up, we know we can get liquid water. We've seen on the previous slide that both of these are made up of water molecules, individual H2O molecules. So heating up ice and melting it to water does not change the chemical composition of the substance. It just changes the physical appearance. If we heat liquid water up even more, we get steam. Steam is just a bunch of individual water molecules that have a lot of energy and they're moving around very quickly. So going from solid ice to steam is just a physical change. We haven't altered the chemistry of any of the material that's there. Another example is, let's take a carrot. And when I was a kid, I hated eating carrots. But my mom would always put carrots on my plate for dinner. You have to eat these carrots, it's going to give you good eyesight. All of those types of tales that parents tell their kids to eat their vegetables. So in my mind, I thought, well, if I cut this carrot up into really, really small pieces, it'll look like I've eaten a lot of the carrots. And then my mom will say, okay, one more bite and you can go. You can leave the table. So what I would do is I would chop up my carrots, I would chop up my vegetables into little tiny, tiny pieces and say, look, Mom, I've eaten my carrot or vegetable. Well, my mom would come back and say, I know you just chopped it up into smaller pieces. Those are still carrots. They're just smaller pieces of carrots. So this would be considered a physical change. I haven't altered the chemistry of the carrot. I've just changed the the shape, the form of that carrot. So alas, my mom was smarter than I was when I was at 5 years old, and so a carrot is still a carrot. I still had to eat all of my carrots, although they were smaller pieces now. So if I take a glass and I drop it on the floor and it shatters into a million pieces of glass, it's still glass, it's just smaller pieces of glass. So those types of changes are considered physical changes. Let's move on to the chemical changes, the chemical properties. We're chemists for a reason, so let's talk about these chemical changes and chemical properties. So a chemical property is the property a substance shows as it interacts or transforms into another substance. So we can take fireworks, for example, and we can see some of its chemical properties. Well, fireworks are flammable. We know that if we have this gray powder and we strike a match to it, it's going to explode. It's going to change color. It's going to smell differently. And so we have some of those chemical properties. One of the chemical properties is flammability. Another one is reactivity. We know that that firework reacted with the oxygen and heat. So if we burn something, we're going to be adding oxygen into the system. So we know that fireworks are both flammable and reactive with oxygen. And then toxicity is another chemical property. If you ingest something that's very toxic, it has very negative effects on your body. So we want to make sure and talk about this chemical property before we ingest something. So these are ideas of what chemical properties are. There's many others, but I only wanted to show you 3. What are some measurable chemical properties? The ionization energy. We're going to talk about this a little bit later. This is the amount of energy required to strip off an electron out of an atom. The electronegativity. This is something that we're going to be discussing later as well. This is the amount of the ability of each atom, of each element, to kind of draw electrons towards it. And the more it can draw electrons towards it, the higher the electronegativity of that atom. So these are measurable chemical properties. So like we did on the physical properties, let's talk about chemical changes, the more interesting aspects of these chemical properties, in my opinion. Chemical change occurs when the chemical properties of the products, the final products, does not match the chemical properties of the starting reactants. So this is pretty easy to identify when a chemical change has occurred. A simple example of this, this is just a made-up example, but if we have a blue circle and we have a red square and they react with each other to form a purple oval, we can see the physical change. We've seen a physical change. It's no longer the same shape. The color has also changed. Color changes are generally indicative of, or they generally indicate a chemical change. The chemistry of this purple will not be the same as the chemistry of either the blue or the red. It'll be some combination of the two. And so this shows a chemical change. The properties of the right-hand side of the products do not match the properties of the left-hand side, the reactants. Maybe a better example of that would be to take liquid water and run a very high electrical current through it. If we do this, we can separate out the hydrogen and the oxygen from water, separate those two things out, and we can actually produce hydrogen gas and oxygen gas. So let's look at some of the chemical properties. Let's take flammability. Let's just take one chemical property. Let's take flammability. Water is not flammable. I could take a match, I could put it on water, it's not going to burn. If I take a match and I put it to hydrogen gas, it's going to react. It's going to blow up. It's going to catch on fire. So the flammability test for hydrogen is the outcome of that flammability test is actually very different than that of water. Same thing for oxygen. You light it with a match, it actually blows up as well. So the products do not have the same chemical properties as the reactants. Chemical changes occurred.